Okay. Uh, Thank you, everyone. We'll start with the virtual machine migration methods. And today's agenda is migrations overview. Mainly, we have three types of migrations: vMotion, SvMotion, and also the cross-host vMotion. So the first concepts are covered with the vMotion, and the second we'll talk about the SvMotion architecture and use cases. And finally, we can end the session with cross-host vMotion and also vMotion between the multiple vCenter servers. Okay, for all these concepts, we'll verify in our home lab. And migrate virtual machines overview. Migration means moving a virtual machine, and there are multiple scenarios to migrate the virtual machine. Migrate a VM from one host to another host, and migrate a VM from one data store to another data store. And we can also migrate a VM from one vCenter to another vCenter. So if you want to migrate a VM from one host to another host, technically we call it as a vMotion. And if you want to migrate a VM from one data store to another data store, we call it as a storage vMotion. And suppose if you are migrating VM from one vCenter to another vCenter, we call it as it's like a cross-host migration or long distance migration. There are multiple names we have for these migrations. Okay. And most of the migration, there will be a two types of scenarios. Either it is in a cold migration or hot migration. Normally, sometimes when the virtual machine is in power off state, we consider as a cold migration. When the virtual machine is in power on state, we consider that migration as a hot migration. So wherever we use cold and hot, no need to confuse that. The actual keyword for cold is VM power off state. Hot migration means VM is in power on state. Okay. So now, as per our VMware configuration maximum guide, we are going to observe the migration limitations and also the comparisons now. So types of migrations, we have the mainly the 5 types of migrations available in our VMware vCenter. One is cold, another one is suspended, vMotion. vMotion, another name is hot migration, or we call it as a live migration. And we also have storage vMotion and shared nothing vMotion. So shared nothing means normally for vMotion and storage vMotion scenario, most of the time we require a shared storage. But recently in from vSphere 6 onwards, VMware introduced a new feature called shared nothing, or we can say non-shared data store vMotion. Even if your ESXi host do not have a shared data store, still we can able to perform the vMotion that is called shared nothing vSphere vMotion. So and try to understand the definitions for each migration type. So cold migration means migrate a power of virtual machine from a ESXi host to new ESXi host, or you can also migrate power of virtual machine from a data store to new data store. And suspended means virtual machine should be in a power off state. When the virtual machine is in a suspended state, there is a separate option for suspended is nothing but a VM paused state. Suppose if we quickly log into our vCenter server, within our vCenter server, let's say I just power on the our workstation, all the VMs. Okay, let's log into our vCenter server. When we log into the vCenter server, see, currently we have one data center. Under data center, we have cluster and 4 ESXi hosts, and there are two VMs, and also we have another spare cluster. Okay, so if we want to verify the virtual machine state, let's say currently the app VM, it is in the power on state. That means it is in a live VM. And when the VM is in power off state, that means it is kind of cold state. Okay, and now what they are saying is suspended migration. Suspended means when we right click the virtual machine, go to the power, there is an option for suspended. But normally we can suspend only the power on virtual machine. So let's power on. So now VM is in power on state. And now if you want to make this VM to suspend, go to the VM, right click, power, and you can choose the option suspend. When we select the suspend option, see the VM green color will be changed to suspend state now. So you can see the yellow color here. This is in a suspend, even in the box it is saying as VM is in a suspended state. Okay, so normally when we require some scenarios we recommend to do virtual machine suspend state. One example use case for the suspended state is, let's say my virtual machine is unexpectedly restarting, or virtual machine is suddenly down or corrupted. Any scenario, normally we will raise the request to the VMware first. The primary our vendor support will be the VMware vendor only. But some cases VMware also recommend that virtual machine level there is no issues, but there will be a possibility to find the root cause from the guest operating system level. So guest operating system means our virtual machine can run with either Windows operating system, Linux operating system, or Solaris, any other operating system. Suppose we will talk about the Windows operating system. If it is a Windows operating system, your real production server, you are getting an issue like virtual machine unexpectedly restarting, or virtual machine is affected with a blue screen of death. Blue screen of death means it's a virtual machine will shows the blue screen and immediately it will power off. During that scenario, what Microsoft vendor recommend is you can just place the virtual machine into suspended state, and then you can try to export the virtual machine logs, because when the VM is in power on state, the live logs we cannot generate. If the virtual machine is in the suspended state, it will create some memory dump file in your virtual machine folder level. Virtual machine folder means that virtual machine folder is stored in our data store. So go to the data store and export that memory dump file. In order to generate that memory dump file, our virtual machine condition is we need to place it into a suspended state. Okay, that is the importance of this option, suspended option. Suppose if the suspended state, your virtual machine unable to export the log from one ESXi host, during that scenario, you can use suspended migration. That same suspended VM, you can just log into vCenter, right click the virtual machine, you can choose the option for migrate. So suspended VM also we can migrate. So while migrating the virtual machine, there are four options are available by default. See the first option, change compute resource only. And compute resource means it's changing the ESXi host. Migrate the virtual machine to another host. So migrate virtual machine to another host means we are just migrating VM from one ESX to another ESX. So normally this first option recommended for a vMotion only. Suppose change storage only. Storage only means manage virtual machine storage to a compatible data store or data store cluster. This option is recommended for a storage vMotion. And the third option, change both host and resource and storage. This means when you want to do this option, our virtual machine should be in a power off state. So power off means we can use cold migration. This is the third option. And cross vCenter server export. Suppose you want to migrate your virtual machine from one vCenter to another vCenter. Like my primary data center is in Hyderabad location, my secondary data center is in Delhi. So I want to move my primary data center Hyderabad to, I want to move my VM to the Delhi location. That is nothing but a cross vCenter export. So this is a cross vCenter level migration. But where is a suspended state? So for the suspended state, relevant option suspended and cold states, the recommended option is third option. Okay, when you select this one, you can able to migrate our suspended VM to either any of the ESXi host level, any host we can select. When you select the ESX host, it will give some warning messages, compatibility checks it will choose. Suppose if I choose another host, compatibility checks are succeeded. So wherever you have the compatibility option, there you can migrate. Okay, so before discuss the all migration option, just try to understand the quickly what is the main four methods of migrations. So the first option for vMotion, compute store, and storage only means storage vMotion. Change both compute and storage means it is a cold migration or suspended migration. And last option is cross vCenter server migration. Okay, so these options only I am trying to elaborate from our slide. So suspended vMotion, remember that whenever we have a guest OS problems, that time only we recommend to choose. Even Red Hat VM, there is one unexpected Red Hat OS level issues. To find the root cause, our Red Hat vendor recommend to do suspend the virtual machine, then you can export the log files. So during the suspended state, it will clearly write what the problem in our guest OS level. So we need those logs to analyze the server virtual machine health status. Okay, or else most of the time we'll do a normal vMotion, SvMotion, or shared nothing vMotions only. So whenever necessary, that time only we'll go for a cold and suspended state migration. And now let's talk about a vMotion. vMotion, another name, hot migration, or we call it as a live migration. So vMotion definition is migrate a power on virtual machine from a host. Host means from one ESXi host to another ESXi host without downtime. So no need downtime for the virtual machine. We can migrate. For example, let's say quickly log into our vCenter. Just right click the our virtual machine, right click and go to the migrate. When you select the migrate, you can choose the option compute resource only for a vMotion option. So just select, click on next. So there are multiple hosts are available. Which host you want to migrate, you can choose any random host, let's say ESX2. When you select the ESXi host, click on next and it will choose the default VM network. We no need to change any option because compatibility status is succeeded. Next, and CPU resources, you can use the CPU resource same as a existing ESXi host. Click on next and ready to finish. So when you click on finish, you can go to the recent task or you can go to the virtual machine monitor tab and tasks. You can see our relocate virtual machine status is completed. When I expand here, you can see some additional options. See relocate virtual machine completed and target VM is app VM1. This is a vCenter. See how long it took, very within fraction of seconds, it's migrated to another ESX host. This is called live migration or vMotion or hot migration. Okay. Now let's back to the another definition. Storage vMotion. Storage vMotion means migrate a power on virtual machine files. Here it's not a VM. We are migrating the power on virtual machine files from one data store to another data store without downtime. So here we are not changing the ESX host. We are just changing the data store only. So during this scenario, let's log into the vCenter again. Let's say this ESXi host is running on ESX2. And when you go to the data store tab, you can see currently we have a only the data store is a shared data store available. We'll quickly check in our ESXi2, do we have local data store or not? Go select the ESX2, go to the data store, see, you can able to see both data store. Suppose I want to migrate my virtual machine from my local data store, shared data store to local data store. Yes, that is option also possible. So if you want to migrate that way, let's say the same new virtual machine where it is running, it is on the 74. Okay, let's select the app VM01 and our virtual machine size is 15 GB. So right click the virtual machine and you can select the migrate. When you select the migrate and you can choose for SvMotion, a relevant option is change storage only. So select change storage only. It clearly says that migrate the virtual machine storage to another compatible data store. Okay, so select that option, click on next. So when we click on next, it will show you all your available data stores. But in the real-time scenario, we have a multiple data store, shared data store. But in our test lab, per present available storages are one local data store, one shared data store. Let's say I want to migrate to the local data store. Select the local data store. See the compatibility is succeeded. So that means we are moving the virtual machine from ESXi to local. Again, if you want to verify again, let me cancel, select the virtual machine. And if you go to the data store tab, this VM is running on a ESXi data store. Now I'm going to migrate this VM from this data store to another data store. If you want to move to another data store, right click the VM. But remember, this host is running on a ESX2. So we are not changing the host status. We are just changing the data store status. So right click the VM, go to the migrate and you can choose change it to storage only. Change storage only means we are just changing storage only. We are not changing the ESX host. So select your destination data store and click on next. And now click on finish. If you notice earlier, vMotion was completed within fraction of seconds. But when comes to the storage vMotion, we are migrating the data, 15 GB of disk we are migrating. So it's not like vMotion quick fast. It may take little time to migrate from source data store to destination data store. So if I expand here, so you can see the virtual machine relocation is in progress. Even in the recent task, you can clearly see the information. migrating virtual machine from ESX2 to ESX2 iSCSI data store to it's migrating to local data store. So migrating is in progress. So currently the status is 43%. So 15 GB migration means it may take little time to migrate. Okay. So in the meantime, we'll discuss the another point. So hope you understand the difference between vMotion and SvMotion. vMotion means the mainly we are changing the host, and SvMotion means we are changing the one data store to another data store. And storage shared nothing vSphere vMotion. Shared nothing means normally for the vMotion purpose, VMware recommend to maintain a shared data store. But from vSphere 6 onwards, VMware introduced a new feature. Without shared storage also, you can able to perform the virtual machine migration. But only condition for this is it will migrate through our network. So that means we required a vSphere distributed switch configuration. If you have a DV switch configuration, distributed virtual switch, you can able to perform this migration. And here the definition is migrate a power on virtual machine from a host or data store to a new host and data store simultaneously. So that is nothing but a shared nothing vSphere vMotion. Now try to understand the what is the some additional comparison between all these migrations. So cold, suspended, vMotion, storage vMotion, and shared. Whatever we have 5 migration, all 5 migration I just entered here again, and understand the virtual machine state. So cold means VM is in a power off state. Suspend means VM is in a suspended state, and remaining all the three vMotion, shared storage vMotion, and also shared nothing vSphere vMotion. All these three states, virtual machine is in a power on state. And change host or data store. Suppose in a cold migration scenario, what is the changes to my VM? My VM, both host and data store will be changed. And suspended state, even suspended state, if you migrate also, all your virtual machine host and data store will be changed. And vMotion means the change is only the host only change. Data store still the same. When comes to storage vMotion, here only the data store will be changed, and ESXi host still run on the virtual machine runs on the same ESXi host. And shared nothing means again we have a facility to modify both. Okay. And across vCenter instances. Suppose if I want to migrate my virtual machines across vCenters, so cold migration also we can do. When the virtual machine is powered off, you can migrate from one vCenter to another vCenter. Even suspended VM we can migrate, and power on VM also we can migrate. Storage vMotion we cannot migrate. There is no default storage vMotion across vCenters, but we have option only for a shared nothing. Without shared data stores, we can just change the virtual machine from one data store to another data. That option is available. And shared storage required. So in which scenario we require a shared storage? For cold and suspended, no shared storage. Without shared storage also we can migrate. So shared storage means we have examples for shared storage is FC SAN, iSCSI SAN, FCOE SAN, NAS storage, and also vSAN virtual volumes. In our previous sessions, we discussed about how to configure all the storage concepts. So these all storages is allows you that the main key feature is shared storage between the vCenters, between the ESXi host and clusters. And cold and suspended VM, if you want to do a power off virtual machine migration, we no need a shared storage. We can migrate when the VM is in power off state. But in the hot migration scenario, VMware recommendation is we require a shared storage. And storage vMotion also, without shared storage also, we can able to migrate the VM from one data store to another data store. And the shared nothing also doesn't require a shared storage. And CPU compatibility. This is one of the important point, CPU compatibility. If you want to perform a migration from one host to another or one data store to another data store, CPU family should be allowed. So different CPU families allowed. Different CPU family means, let's say my one ESX host is running with the Intel processor and another ESX host is running with a AMD processor. In our present current markets, the most popular CPU vendors are Intel and AMD. We also have some other third-party vendors, but most popular vendors, even if you see in your laptop also, there is one label says Intel Core i7 or i10 is inside. So Intel means that is Intel processor is running in your laptop. Same way in our server infrastructure also, most of the popular server CPU families are Intel, AMD. if I'm planning to migrate VM from one of the Intel CPU hardware to another AMD hardware, during that scenario, VMware recommend that you need to power off the VM, then only we can migrate. If your CPU families are same CPU family, you can go with a vMotion. Hot migration must meet CPU compatibility requirements. So CPU compatibility requirement is both ESXi host source and destination must run with a same CPU family. If your destination in a different CPU family like AMD, our hot migration is not possible. So during that scenario, we need to power off the VM and migrate. Okay. And suspended also same, must meet the CPU compatibility requirements. And also storage vMotion, there is no CPU requirement. Whatever the storage you have in the destination, either it is a vSAN, virtual volume or different NAS storage also, you can able to migrate. And the shared nothing also must meet the CPU compatibility requirements. That means if you want to do this action, both source and destination should be in a same CPU family. Okay, and if the CPU family is different, only solution is power off the VM and migrate. So this is a high level overview of types of migrations and comparisons. Now all this migration we'll talk about in detail in the subsequent slides. See, this is our regular, one of the common important point in our vCenter concurrent migration limits. So what is our main migration limits? So before we talk about this table, let's try to understand this diagram. If within this diagram, we have two ESXi host and ESXi host is connected with a network, physical network, and both ESXi host also have a shared data store. And each box is running with ESXi operating system and also ESXi created a multiple VMs. So vMotion is nothing but a moving a running virtual machine from one ESXi host to another ESXi host. That is called vMotion. Suppose without changing my host, if I move from one data store to another data store, that is nothing but a SvMotion. So here, what our VMware recommendation is vMotion operations per host. If your network speed, physical network speed is 1 Gbps network speed, during that scenario, concurrent, that means simultaneous migrations, we can run max 4 VMs at a time per one host. Suppose vMotion operations, yeah, I'm trying to migrate not only single VM, multiple VMs per host, but my network speed is 10 Gbps. If your network speed is 10 Gbps, at a time 8 VMs also we can migrate. Suppose my ESX host is running with a 10 virtual machines. 10 virtual machines means the 8 VMs set, 8 VMs can migrate at a time concurrently. And once the 8 VMs are migrated, then only the remaining 2 VMs will start the migration. Until that time, the out of 10 virtual machine, once the 8 VMs are migration is initiated, the remaining 2 VMs will be in a queued state. It will be in a queue. Once 8 is finished, then only the remaining 2 VMs will start migration. Okay. And not only 10 Gbps, suppose if your vMotion physical network speed is more than 10 Gbps, our simultaneous count will be increased. Okay. And vMotion operations per data store. Even within one data store, you want to migrate VM from one folder to another folder, one data store to another data store. This and all, it will take simultaneous migration at a time, 128 migrations we can do. Okay. Per data store level. And the storage vMotion operations per host. Within one host, how many storage vMotions we can do is only 2 as per VMware configuration guide. And the storage vMotion operations per data store. So earlier point is per host, but this point is per data store, max is 8. And non vMotion provisioning operations per host is 8. And these points are normally, it may useful when you are attending the interviews. That time you may expect these questions from interviewer, or in our VMware certified professional exam also, you may expect these questions, maximum limits questions. Okay. During that time, these points are important. Normally, our daily day to day while working in the operations, we no need to worry about these limitations. But for the interview perspective and for the certification perspective, we need to learn this configuration maximum limits. Now, we are going to talk about the virtual machine vMotion overview now. So definition we are familiar. vMotion can migrate a running virtual machine from one ESXi host to another ESXi host without any downtime, or we can say no disruption. So there will be no disturb to the end user. Suppose these three VMs running my end user, my customers are using, even the customers, we no need to inform on the live, you can migrate within a fraction of seconds, VM will be migrated to another host. Okay, that is the importance of vMotion feature. And VMware vSphere vMotion changes the compute ESXi resource only. So as we know, vMotion means data store is still same data store, only the host status will be changed to ESX1 to ESX2. And with vSphere 7.0, migrations can take place. We can perform migrations all these scenarios. You can perform migration from cluster 1 to cluster 2 between the clusters, and between data stores like data store 1 to data store 2 migration. You can also migrate between networks. Even if you want to migrate your virtual machine from production network to development network, or development network to production network, vice versa. That migration is possible. And between vCenter servers, even you have a one production vCenter is in Hyderabad and the development vCenter is in any of the remote location. So from development vCenter to remote location vCenter also we can migrate, and it will support for a reverse way also. That means vice versa. And over long distance with round trip time of 150 seconds, even your data center, let's say Hyderabad one data center, Pune also one data center, both vCenters and ESXi hosts connected in a same vCenter using a vCenter linked mode, or you can also configure both ESXi hosts, different location ESXi hosts also in a same cluster. But that consider as a over long distance migration. That over long distance migration, usually it will take RTT of 150 seconds. RTT means round trip time. Okay, and cross cloud means normally our existing data center, we call it as a on premises data center. If you want to migrate your VM from on premises to private cloud, private cloud means VMware vCloud Foundation, it runs with a vRealize automation. So if even if you want to migrate VM from on premises to private cloud or on premises to any other clouds, also can possible. So these are the migration scenarios we have. So it depends on our customer requirement and our main objective. Based on our objectives, we'll perform the relevant migrations. Now we can talk about vMotion key capabilities and use cases. So vMotion key capabilities and use cases, or else sometimes in interview also you may expect why we go for a vMotion, in which scenario we need to do the virtual machine migration. So normally there are mainly four scenarios. Within these four scenarios, we can perform the virtual machine, and it is also useful for our vMotion use case. So let's try to understand the first use case. ESXi host maintenance schedule. Let's say in this diagram, we have two ESXi hosts and each ESX running with the three virtual machines. Suppose in future, I want to update my ESXi host version. Let's say my current ESXi host running with the 7.0. I want to update the patch from 7.0 update 1 to 7.0 update 3 patch. While updating your ESXi host patch, definitely it requires a host restart, and we need to place the host into maintenance mode before restart. So while you are placing the host into maintenance mode, there is a power on virtual machines. So what do you do when the virtual machines are power on state? The recommendation from VMware is while you are updating or upgrading. Update means patch, upgrade means version change. So any scenario while updating and upgrading the ESXi host, or any hardware maintenance means suppose sometimes our ESXi host also have a hardware issues like motherboard failure, or CPU processor having some issue, or memory faulty, power supply failure, any hardware scenario also. The before going to attempt the hardware maintenance, VMware recommend that first you can migrate your running virtual machine to another host, then you can perform whatever the maintenance you want. You can perform maintenance on the host hardware level, or you can perform maintenance on a ESXi host operating system level. So during these main scenarios, we'll recommend to migrate virtual machine to other host. So okay, this is the one scenario. And second scenario, insufficient, or we call it as a not enough resources in ESXi host. Let's say my ESXi host CPU and memory is completely full. How we can say insufficient resource means, log into our vCenter. Let's say if I select any ESXi host here, Our lab ESXi host currently running with, see, the CPU resource are free, memory also free, and storage also free. Suppose if my any let's say, see the second host memory is, we have some free memory resource. Some scenarios our ESXi host CPU and memory usage will be full. So during that scenario, to balance the load or balance the ESXi host hardware optimum, if you want to use your ESXi host hardware optimum usage, the recommendation is migrate your one or two virtual machine to another ESX host. So that is also one scenario. So for better hardware utilization or improvement in your overall hardware use, we can perform with a manual vMotion. And another scenario, not enough resources in virtual machines. So it's not only in a ESX host level, your virtual machine requires 64 GB of memory. So if your virtual machine requires 64 GB of memory, we should verify that our ESX host have 64 GB memory or not. Even if your VM required a additional memory. So if your host do not have additional memory, just migrate that VM to another host wherever you have a additional memory on your ESX host. Let's say this ESX host have 64 GB. That means here you can easy to run your virtual machine with high memory. So during the third scenario, even if your VM require additional resources also, you can migrate virtual machine to another host wherever the resources are available. So same point I highlighted here. Continuous VM operation, migrate VM to another host wherever the resources available. And the fourth point is another use case for DRS is another use case for vMotion is DRS. So DRS full form distributed resource scheduler, and DRS is one of the vCenter cluster features. It is a load balancing technique. In our next class, I will explain in detail of DRS, but in this session, just understand the point. DRS also one of the load balancing technique, and it is a vCenter cluster feature. And in the background, DRS also uses a vMotion technique to balance the load on your ESXi host virtual machines. Let quickly show you where we can enable the DRS option. So DRS option is log into vCenter, see, select your cluster, right click and go to the edit settings. This is one option. You can go to the edit settings, or another method is select your cluster, go to the configuration tab and select vSphere DRS under services section. When you select the DRS, click on edit. See, try to read this description point. When we read the description point, DRS automation level is fully automated. What this fully automated method does is DRS automatically place your virtual machines onto the host at VM power on state. So when you read this point, DRS also uses a vMotion technique. But only difference is the first point we are performing a migration manual. Even the second point we are doing a manual vMotion. If you want to automate your vMotion feature, the only option is we need to enable a DRS feature in our vCenter cluster level. That's why we call it as one of the vCenter cluster feature. So this option is available only in a cluster level. When I select the cluster, go to the configuration tab. See, currently DRS is in a turn off state. The in detail DRS concept we'll discuss in our subsequent class. But the main key point here is DRS also uses a vMotion technique. Okay. See, we no need to worry about the ESXi host load and all. Instead of doing a manual migration, when you enable the DRS, it will automatically migrate the virtual machines automatically. Let's say in our lab, we have 4 ESXi hosts. It's easy to identify which host have high resources, and you can migrate VMs to another host. Let's think about, instead of my vCenter, instead of 4 ESX hosts, I have a 400 ESX host. See, when you have a 400 ESXi host, it's a difficult to do manual migrations every time. During that scenario, VMware recommend that you can enable a cluster level DRS feature. It will take care of vMotion, all vMotion activities. Okay, so that is importance of DRS. So I repeat, vMotion main use cases are during ESX host maintenance scenario, in case of ESX host insufficient resources, and whenever virtual machine require additional resources, and also for automate your vMotion feature, you can configure DRS also at vCenter cluster level. So these are the main use cases for vMotion feature. Now we'll talk about the vMotion architecture now. See, vMotion architecture components. See, if you want to perform a vMotion, the main key components are we require a multiple ESX host. Let's say in this diagram we have a 3 ESX host, and another key point for vMotion is we require a shared data store. All these 3 ESX hosts must have access to shared data store. How to verify shared data store information is log into vCenter. Let's say go to the data store tab. We have a multiple data stores here. The first one is data store 1. That means it's a local data store. ESX1 local data store. When I select the local data store, go to the host tab. It's accessible for only one host. Even second host, it's accessible for only one host. When I select the iSCSI data store, when I select iSCSI data store right side, when you go to the host tab, see it is accessible for multiple hosts. That means this is a shared data store. So that shared data store only I mentioned here. And can anyone tell me what type of shared data stores we can configure?
vSAN.
Yeah, we can, yes, we can configure the vSAN, and also we can configure virtual volumes, FC SAN, and iSCSI also we can configure. Okay. Okay, so there are multiple shared data store options are available. So anything we can configure, it's a subjected to be our customer requirement. Some customers they may configure a FC SAN, some customers they may configure NFS storage, some may go with a vSAN or virtual volumes, software defined storages. So any storage, but the concept is still the same. We require minimally 2 or more than 2 ESXi hosts and shared data store. We have a 3 ESXi host in this diagram. And to automate your ESXi host load balancing, we require a cluster. So cluster means grouping of multiple ESXi hosts. All your ESX host resources will be grouped, and then you can easily migrate virtual machine from one host to another host. But which scenario will migrate? We can migrate during the host maintenance scenario, or your ESXi host is completely overloaded. There is a CPU is over 80%, memory over 80%. During that scenario also you can migrate. So you can migrate in a two methods. Either you can perform vMotion manually, or if you want to perform vMotion automatically, you can enable a cluster level DRS feature. Okay, that is the main components in our vMotion architecture. Let's talk about the few points here. So vMotion involves transferring the entire execution state of virtual machine from source host to the destination, and primarily happens over the high speed network. And the execution state primarily consists of the following components. So let's try to understand what is the components in our virtual machine. So as we know, virtual machine components are mainly virtual device state, includes the state of CPU. That means virtual CPU, virtual network, virtual disk adapters, and also the graphic adapters, and so on. Whatever the virtual devices we have in our virtual machine, edit settings. When we select the vCenter, any virtual machine, go to the edit settings. These all consider as a virtual device components. All the existing device components, and even you can add some additional components also. So all these are considered as a vMotion consists of all these components, and external connection with devices including networking and SCSI devices and virtual machine physical memory. Whatever the memory we assign to VM, all these components is considered as a our virtual machine state. And generally a single ping is lost and the user do not even know a virtual machine has changed host. So this is one important point. Let's say while migrating the virtual machine, we may expect single ping lost. Ping lost means, suppose if I open the command prompt, if I try to ping our ESXi host, ping -a or ping, I'm just typing to our ESXi host IP address 192.160.10.71. When we ping here, let's say by default it will shows the 4 pings. It says that ping packets sent 4, received 4, and lost is 0. But when we are performing a virtual machine vMotion, what VMware saying that during the vMotion, you may expect a single ping lost. That means one packet may be dropped, but users do not even know when we are performing a migration. Okay. Even earlier we observed if you want to migrate VM, let's verify app VM is successfully migrated to data store or not. Go to the monitor, tasks. See, we did the First we did a relocation. vMotion we did. vMotion is completed within few seconds, and SvMotion also it took from we started at a 12:27 p.m. and it's completed at 12:29. So roughly it took 2 minutes time to migrate from one data store to another data store. But when you see the vMotion concept, within few seconds there is no source and destination time. It's within few seconds it's migrated. So that is the reason user do not even know when you migrate the virtual machine from one host to another host. Okay, this is about the vMotion architectural components. Now we'll talk about technically how the vMotion works. Suppose if I migrate a virtual machine again, just right click the VM where this virtual machine is running, summary tab, it is running on ESX2. I want to migrate the VM from ESX2 to another host. Right click the virtual machine, go to the migrate, and for the vMotion, the relevant option is compute resource only is the relevant option. So select the first option for vMotion, click on next, and here it is showing as only the option is ESX2. And if you want to migrate to the another host, select the clusters wizard. Under cluster wizard you can choose, but currently it is not showing. That means there is a some compatibility issue. Let me select the another host and remove this virtual machine, suspend state, and now this VM is running on 74. Let's right click this virtual machine, go to the migrate. When you select the migrate, click on next, and here it is showing only the one ESXi host because another host is not showing. That means there is a some compatibility issue. So during that scenario, let's select here, go to the virtual machine tab, right click the VM, select migrate, change host, still it is showing as only one virtual machine. The reason for showing only one ESX is when you go to the ESXi virtual machine, and what is our storage? It is our storage is stored on a only a local storage. It is not a shared storage. That is the reason this virtual machine is not showing the our other ESXi host. As VMware says, if you want to migrate VM from one host to another host, our condition is shared data store. So just now we observed when I select the virtual machine migrate and click on next, it is not showing the other host. A reason is our VM is running on a local data store. If you want to see your other ESXi host, the only solution is again migrate back the VM to the shared data store. So if I want to migrate the VM from local to shared data store, select your change storage only option. And now here select a data store, click on next and finish. So again, we may need for 3 minutes to finish the SvMotion task. Once the SvMotion is connected, we can observe the vMotion job again. So in the meantime, I will try to explain how the vMotion works in the backend. But it is a very simple fraction of seconds we are migrating the vMotion. But in the backend, there is some technical concept. That concept I will try to explain now. So how vSphere vMotion migration works. Let's try to understand the diagram. Let's say we are connected to our jump host. From the jump host, one of the user is trying to migrate a VM from ESX1 to ESX2. If you want to migrate VM1 from ESX1 to ESX2, we know that one of the main condition is shared storage. Shared storage means this shared storage contains our virtual machine folder. Inside the virtual machine folder, we have virtual machine disks and configuration files. Config file means .vmx, virtual disk means .vmdk. So this file, we are not changing any shared storage location. We are just changing the VM ESXi1 to ESX2. But if you want to do that one, how we can perform is when you log into vCenter server, right click the virtual machine, select migrate. When you click on migrate, what it will do in the background is it will start migrating from ESX1 to ESX2. But there is no storage level changes. Only the VM is moved to ESX2. But in the backend, it will prepare a memory bitmap. Bitmap is nothing but it's a memory page file. Whatever the changes we run in our normal system. Let's say in our laptop, you open one Word document, you are typing something. When you type something, the initial storage is stored on a RAM only. That is called primary storage. When you save your document, then the secondary storage will be your laptop hard disk. It will store in your laptop hard disk. Similarly, if you want to migrate your virtual machine also, Just a minute. Someone trying to log in. Okay. So similarly, when we are migrating a virtual machine from one ESXi host to another ESXi host, the initial stage, the memory, it will prepare a memory pre-copy file. That pre-copy file, we can also call it as memory bitmap. This bitmap, whatever the changes user is running on the virtual machine one, all the changes, minor changes is stored on a bitmap. But the bitmap will slowly move that bitmap from ESX1 to ESX2. But that is why I am showing this arrow. The memory bitmaps are moved to the ESX2. But how it will move the ESX is, normally for virtual machine access, we are using a virtual machine network port group. That port group, you can use VM network name, or you can create this any customized names like production port group. This is a virtual machine production port group. But this virtual machine production port group is only for a user access purpose. But in the back end, if we want to perform a virtual machine vMotion, we require a additional port group that is called VMK port group. We know during our ESXi networking class, we discussed VM kernel port group purpose. VM kernel port group, it allows you to access your ESXi host, and also it will help you for the some additional ESX host services. That services, one of the service include vMotion. Okay, so if you want to perform a virtual machine migration from one host to another host, the main requirement is shared storage, and also we require a VM kernel port group. So this VM kernel port group we can create on our ESXi host virtual switch, or you can create on our distributed switch. So some, because some companies they may not have a license for distributed switch. During that scenario, you can configure VM kernel with VM kernel port group with vMotion service on a standard switch level itself. Suppose your company have a enterprise plus license or enterprise license. That scenario, you can instead of configuring a VM kernel port group on a vSwitch level, you can directly configure VM kernel port group with vMotion feature enable on a DV switch level. But how to configure port group for vMotion and all, I think we already know. I quickly show you. Suppose if you want to configure on a standard switch level, select the ESXi host, go to the configuration tab, and when you select your VM kernel adapters, see we have only one VM kernel adapter. Let's say if you want to configure one VM network adapter for vMotion, click on add networking. You can choose VM kernel network adapter. See, it clearly says that VM kernel TCP/IP stack handles the traffic for ESXi services such as vSphere, vMotion. See, if you need a vMotion service, we need to configure one dedicated VM kernel port group. So these options we know how to configure VM kernel port group on vSwitch level. Suppose if we want to configure same VM kernel feature in DV switch level, how we can configure is go to the networking tab. Under networking tab, you can select your distributed switch and go to the configuration tab and select the actions. Under the actions, you can see the options. Let's say you can configure this as a new DV switch distributed port group, and we can also when you click on new port group, it seems to be this is a normal port group like a virtual machine port group only. If you want to configure dedicated one, let me see the option. Select the port group. When we select the port group, go to the actions. There is an option for add VM kernel adapter. So this option we can use to create a VM kernel port group with vMotion service on DV switch level. So I repeat, instead of selecting the DV switch, if I select the DV switch and go to the action, there is no VM kernel add option. Okay, so if you want to add a additional VM kernel port group with vMotion service, select your DV port group. So I just selected distributed port group, and now go to the actions. Now you can see the option for add VM kernel adapter. When you click on add VM kernel adapter, here we have an option to add attached host. So we can add your ESXi host. You can select all the three hosts, click on OK. And when you connect the three ESXi hosts, all these three ESXi hosts, you can enable a vMotion feature. So when you enable the vMotion feature, it will allow us to configure a vMotion VM kernel port group. So individually, you can configure the IP address for ESX1, ESX2, and ESX3. Okay, so this is the option I'm trying to explain here. To migrate virtual machine from one ESXi host to another ESXi host, the requirement is we required VM kernel port group with vMotion service, and virtual machine traffic will take care by VM network port group, or you can put in customized names like production port group. So this is how the virtual machine will migrate from ESX1 to ESX host through the memory bitmap. It will send the memory bitmap first from ESX1 to 2. Maybe after migration, user may do some additional changes. Even that changes also memory bitmap will send until whatever the users stop the changes, all the changes will be moved to VM1. Once it's moved to VM1, and once it's moved to the ESX2, then this VM will be automatically removed from ESX1. It will start working from a ESX2. But all this process will activate within fraction of seconds, and there will be no changes on your disk data. Only the changes is whatever the resource this VM is consuming from ESX1, like CPU, how much CPU, how much memory, those resource information only changed from ESX1 to ESX2. And also in our ESX1, let's say VM1 is running on vSwitch1. This vSwitch1, it's just the switch information, port information updated to ESX2 switch, ESX2 port. That is only the change is happen when migrating VM from one ESX host to another ESX host. But in the some of the interviews, they may also ask you some deep dive questions, how the memory bitmap is really working during the virtual machine migration scenario. That point also I will explain in the following slide. But hope you understand how we migrate the VM from one host to another host. Some more in detail technical concept I will explain in the next slide. See, let's try to understand all these points. These points are important. Most of the interviews they will ask how the vSphere vMotion migration works. So that time you can try to explain all these 8 points. The first point is a shadow VM is created on a destination host. Shadow VM created means if you see in our previous diagram, we have VM1, there is a shadow VM is created. That is the point. So shadow VM is created on destination host, and the virtual machine memory state. Memory state means whatever the user is currently using the VM1, the current memory state is copied over the vMotion network. vMotion network means our VM kernel port group enabled with vMotion service. From source host to target host, the memory host copying and all is taken care by this option. Only this port group will take care of copying. See the memory copy moving from through the vMotion network, it's moving to the destination. And users can continue to access the VM. Even users can continue to access, there will be no impact to the virtual machine, and potentially update memory pages. So whatever the changes on our virtual machine level, that is considered as a memory pages that potentially update the memory pages. A list of modified pages in memory is kept in a memory bitmap. Okay, that memory bitmap word means whatever user did the changes, all is considered as a bitmap or image file. So that memory bitmap image file on the source ESXi host. After the first pass of memory state, the first initial it will pass one time. So one time it will pass the memory state file completes. Another pass of memory copy is performed to copy any pages that changes during the last iteration. Okay, this iterative memory copying continues until no changed pages remaining. Okay, until that time, this memory bitmap will keep copying the information from ESX1 to ESX2. After the most of the VM's memory is copied from source to host, the VM is quiesced. So quiesced means is nothing but your VM is in a stun state or VM is in a hold state. So during that time, no additional activity on the VM. So in the quiescent period, vMotion transfer the virtual machine device state. Device state means whatever the virtual machine devices, vCPU, vMemory, vDisk, and all will be migrated to the destination. The virtual machine is initialized and start running on a target host. And there is another key point is a gratuitous address resolution protocol, in short form GARP. So this request notifies the subnet that VM1 MAC address is now on a new switch port. Okay, because earlier it was on ESX1, now this VM is running on a new new switch port on ESX2. And users access the virtual machine on target host instead of source host. Even users also, they will not know VM is already migrated to second host. Okay, and the memory pages that the VM was using on the source host are marked as free. Let's say here the virtual machine is running with the 4 CPU and 4 GB memory. That 4 CPU 4 GB memory resource will be free on ESX1. That 4 CPU 4 GB resource will be started consuming from destination host. Okay, that is the last point. Now, again, that memory bitmap is a main key point here in our vMotion migration scenario. We'll try to elaborate some more deep dive. Okay, vMotion workflow deep dive. So in this deep dive, if you try to understand the actual workflow, we have source ESX host, destination ESX host, and we have a shared data store. And our main condition is to communicate between ESX1 and ESX2, we require a vMotion network, which is VM kernel with vMotion enabled service. My VM is currently running on source ESX host. When I right click the virtual machine and select the migrate, let's say in our vCenter server, click on cancel. If I want to migrate the virtual machine, go to the cluster, select your virtual machine, right click and migrate and click on next. Let's say I'm selecting the ESXi host. Compatibility is success. When I click on next, it will within fraction of seconds, virtual machine is migrated. See, relocation is completed. So migration is going very fast, but in the back end, how it is migrating is that is this concept. So virtual machine is on source ESX. When I click on migrate option, what it will do is the first step is create a VM on destination. So it's create one VM on destination, but completely this is in a hide state. The second step is see the copy the memory to the destination. Whatever the user changes on the VM1, that changes will start copying from source to destination. But the copy is very fast, not like minimal because we are using already shared data store. So it's very fast. It's like in your local laptop, if you copy any file from C drive temp folder to C drive other folder, it's obviously copy is very fast. So same way here it is copying. Once the copy is completed, the virtual machine suspend the VM on source. Suspend the VM on source means, see the VM is in a gray color. This VM is suspended here and transfer the device state. Device state means whatever the virtual machine have devices, CPU, disk and NIC, all this information is updated here. Only the information, there is no data changes. Okay. So transfer the device state and then resume virtual machine on destination level. So VM is already resumed on a destination level. And then this process is called it as suspended VM on source and switch over the time to the second destination. So, but the switch over time, what is the time here? Only the 1 second only. So if you within 1 second, the virtual machine is completely migrating from source ESXi host to destination ESXi host. But in the backend process, whenever any interviewer asks the deep dive question, that time you can explain. Initially, it will start the copying the memory file. So whatever how we discuss the same way you can explain. Whenever we initiate the virtual machine migration, first it will start copying the memory from source to destination and then suspend the VM on a source and it will transfer the virtual machine device state and finally resume the VM on destination. And usually the switchover time from source to destination is only the 1 second only. Okay, once it is copied, this VM is disappeared here. See the power of VM on source, and also it's completely removed and disappear from the source. It will start activating from a second host. But all this process within a second we can finish. But in order to finish within a second, again VMware says that there is some conditions apply. So even in the real-time scenario, some of there will be some offers to buy anything, any product or any online sites. When you are buying anything, there will put you some star mark, conditions apply. So same way, VMware also, they given a vMotion deep dive concept to do very fast migration within a fraction of seconds. But in order to do this fraction of seconds migration, they are giving some conditions. We all meet that vMotion requirements, then only we can perform this migration very fast. Suppose whatever the conditions VMware says, if it doesn't meet the vMotion condition, that migration will be always slow. Okay, so conditions apply for the migration scenarios. Let's talk about the some more in detail point, like some interviews they will ask, can you explain exactly when the VM is suspended on source, when it is migrate on destination, you are saying switchover time is 1 second. Can you elaborate only this layer, what is happening in the backend? So that scenario, only from point number 3 to point number 5, what is the inside actual work, I will try to explain in the next slide. Okay, see vMotion execution switchover process deep dive. Only the switchover process I'm trying to explain. Earlier we covered the complete process from 1 to 6 points. Now I'm trying to explain on a switchover process from 3 to 5. Here the first option is during the before switchover, the quasi VM. Quasi VM means the virtual machine will be in a stun or in a hold state. There will be no changes during the time. After that, it will transfer the checkpoint. Whatever the memory pages available, that memory pages will push it to the destination. And transfer changed bitmap. Even the bitmap also changed from source to destination. And then the swap file, whatever the swap file we have in the source VM, that swap file also updated with a destination host detail. So that point, some more elaboration is, this is the key point here. The functions of virtual machine memory size, 1 GB memory. Suppose my VM is running with 1 GB, the actual bitmap size is 32 KB. And suppose my virtual machine memory is 24 terabyte. If your VM is running with a huge memory, that time bitmap size is 768 MB bitmap. But normally what VMware says is, usually virtual machine migration is fraction of seconds, but there is a one condition. If your virtual machine is running with high memory, you may expect a slight delay during the migration scenario. Even if you have a 24 terabyte memory also, it's a 768 MB. 768 MB within a network copy is very quick copy only, but only compared to the less size of VM, if you have a high memory VM size, the migration will be little slow. Okay, transfer the remaining pages. Once you swap and every changes is copied, again it will do the double check. Whatever the any pages is updated on the source level, all the remaining pages also it will transfer to the destination. And finally, it will resume the VM on destination level. Destination means destination ESX. So from 1 to 6, the switchover time is less than 1 second. And switchover means during the time VM is in a quasi state, or we call it as a stun time. Okay, stun or hold time. So this is an important point. Some of the interviews you may expect this question. Now we'll talk about vMotion requirements. If I want to migrate VM from one ESXi host to another ESXi host, as I mentioned, we have to meet some minimum requirements. So that requirements we'll discuss here. So vMotion requirements are, we'll talk about the ESXi host level first, and then we'll talk about the virtual machine level. If I want to migrate the virtual machine from source to destination, this requirement should applicable for both source and destination ESX. So that's why I highlighted here, source and destination ESXi host must have the following characteristics. So what is this requirements? We can uh, discuss one by one. So first point is VM kernel port with vMotion enabled state on both ESX host. Both ESX host means our source ESX and destination ESX, and matching the management network address families IP version 4 or IP version 6 between source and destination host. Let's say if your source ESX host is running with IP version 4, even our destination host also should use the same IP series, IP version 4. And if you're, some companies they already started using IP version 6. So if your host is running with IPv6, destination host also must be in a same IPv6. If it is in a IPv4, our migration will fail. Okay, so hope we are aware of IP version 4 and IP version 6. Can anyone tell me what is IPv4 addressing? Is it 32-bit addressing or 128-bit addressing?
32-bit.
Yeah, IP version 4 is 32-bit address. So when we are migrating VM also, we should match the same addressing in our destination ESX host. And also to migrate virtual machine on both ESX hosts, the minimum network speed is 1 Gbps LAN code. Suppose if your LAN speed is less than 1 Gbps, definitely vMotion may fail, because the VMware clearly say the requirement to vMotion is 1 Gbps speed. And if your environment is running with more than 1 Gbps, like 10 Gbps network or 20 Gbps network, it will be very additional advantage. Migration will be quick, very faster. And ESXi host CPU family. CPU family should be same Intel CPU on the both ESX host, or you can use AMD CPU family for both ESX host. Okay, this is also important point. And another one, both ESXi host CPU mode or technology generation should be same. Let's say CPU have a different types of generations like generation 1, generation 2, generation 3 in a AMD, but in the Intel the generations they put a different names. They have a generation names like Sandy Bridge, Haswell, Broadwell, Sackwell. These all the generation names. So they can keep any of the generation name. But what VMware saying that if your source ESX host is running with Intel Sandy Bridge generation, in our destination host also must run with the same generation family. Okay, so this information, how we can find the generation information is, we can find the generation information from vCenter level, or you can export the our vCenter server RV tool report. For example, let me minimize our vCenter. In our previous session we exported the RV tool report. If I open a RV tool report, you can see what is our ESXi host, all ESXi host CPU technology and generation information. To verify your ESXi host CPU generation information, open the RV tool report. You can look for a vHost tab. So under vHost tab, let me increase the font. See, there is a multiple options. See, in our vCenter, we have a 4 ESXi host data center cluster. Just scroll down to your right, you will see what is your ESXi host CPU family. All our ESX host is running with the same CPU, Intel CPU. So we already meet the vMotion condition. And what is another point they're saying is CPU, not only the CPU family, even the technology or CPU generation should be same. So that generation, how we can see is in our RV tool report, you can just scroll down to the right, you can see max EVC. Here you will find your enhanced vMotion compatibility. EVC means, so your EVC, where is our ESXi host technology is running is all your 4 host is running on a same technology processor. Suppose here the processor name is Intel Haswell. If my processor is Intel Haswell, both all hosts are same Haswell. So we already meet our vMotion requirement. You can able to migrate VM from one host to another host. Suppose my ESX host out of 4 hosts, let's say 3 hosts are in a Haswell format and one host is in a different format. Instead of Haswell, let's say it is running in a Skylake or different processor model. During that scenario, you will not able to migrate VM from one generation processor to another generation processor. So that is the point they highlighted here. Both ESXi host, CPU mode, technology, any name we can use, technology generation should be same. Okay, so I given some examples. What is the other generations and technologies available in a Intel and also the AMD. Okay, suppose when the if you are using a different generation, if your vMotion obviously fail, how to address that scenario is we need to enable a enhanced vMotion compatibility feature. That feature also I will explain in detail in the following slide. Okay, and another key point, required a shared storage. We know to perform vMotion we require a shared storage or non-shared storage with VDS feature. If you have virtual DB switch, you can also perform without shared storage also, and require a sufficient resources. So we require a sufficient resources to migrate VM from one host to another host. Let's say I'm migrating from ESX1 to ESX2. My ESX2 also do not have enough CPU, enough memory. Obviously migration will fail. So that's why what VMware says is we must have a sufficient resources on destination host. And both ESXi host name, let's say ESXi host name should be fully qualified host name and with DNS resolver. If you remember, when we install the ESX server, our post configuration step is we need to enable the ESXi host DNS record in our Active Directory DNS level. So obviously our all the host is in a fully qualified domain, and also it supports for a DNS resolution. Even if you log into our vCenter server, our vCenter server also, we configured the names as a fully qualified domain name, ESX1.demolab.com, ESX2.demolab.com. That means this is considered as a fully qualified domain name. Okay, so hope you understand the vMotion requirements at ESXi host level. Similarly, we can observe what is the vMotion requirements for virtual machine level. So there are few virtual machine level requirements. So these requirements are, there is no mountable devices. Mountable devices or drives. Let's say your virtual machine is mounted with a CD, DVD or ISO file. During that scenario, it will show you a virtual machine warning message. For example, if I select the virtual machine, let's say virtual machine edit settings. When you select the CD DVD, currently there is no CD DVD connected. If I want to mount a data store ISO file, go to the data store and we can choose the ISO files. So when you any virtual machine mounted with a ISO file, during that scenario also we can able to perform migration, but it will give you a warning message. So that's why they says that just unmount before migration. And encrypted VMs vMotion support. Even vMotion also supported for a encrypted virtual machine. Encrypted is a one of the security feature. For security reasons, all our virtual machine data will be encrypted state. Encrypted means until unless if you have an encrypted password, then only we can decrypt the data, we can read the data. For security reasons, our virtual machine, some of the production servers, they will enable the encryption. This encryption option we can find in a virtual machine edit settings level. Suppose if I right click the virtual machine, go to the edit settings, and here you can go to the VM options tab. When you go to the VM options tab, you can see encryption option. So expand for encryption settings, you can just expand. So when you expand the virtual machine encryption option, you can see the option for encrypted vMotion. So encrypted vMotion also have a three features. So disable encryption, opportunistic encryption and required encryption. Suppose your virtual machine is using this option, any encryption vMotion opportunistic. This feature should be enabled in our destination ESX host also. If your destination ESX host not supported for encryption, we have to configure a encryption. How we can configure is, if you see the above option encrypt VM, if you read the right side sentence, requires a key management servers. So normally in the real-time scenario, we need to buy a separate physical key management servers. So using that key management servers, we need to configure on both the source host and the destination host, so that when you have any encrypted virtual machine, there will be no issues to migrate from source to destination. So this is also one of the condition to reach the vMotion. Okay, so if your source is enabled with KMS server, your destination host doesn't enable with KMS server. That time we may face the issue vMotion failure issue. Okay, same point I highlighted here. Encrypted virtual machines vMotion support is available, and virtual machine network label name should be same. Suppose your virtual machine network label name is production, the same label name should create on a destination level. Okay, and if it uses a RDM disk, even the RDM disk should be accessible by the destination ESXi host. RDM means raw device mapping disk. Normally RDM disk we can see in a virtual machine level. When you right click the virtual machine, go to the edit settings, you can see while adding the device, there is a normal hard disk, or you can use existing hard disk. You can also use RDM disk. RDM disk means raw device mapping. In our later classes, I will explain you how to configure a RDM disk. Okay, so when you have virtual machine with the RDM disk also, it will also, it should be accessible to the destination host, same RDM disk. Then only we can perform the vMotion. And another scenario, our virtual machine, if it uses a multi-writer disk, the name itself says multi-writer. Multi-writer means at a time two virtual machines able to write the data on a same disk. That is nothing but a multi-writer disk. If you have a multi-writer disk on your virtual machine, that should be also accessible by your destination ESX host. But how to configure multi-writer disk is, again go to the vCenter. See, if you select your hard disk, the currently our hard disk state is sharing status is no sharing. That means this hard disk is only dedicated for app VM01 only. So if I want to add a new hard disk, how we can add? Just go to the add new device, select hard disk. When you select the hard disk, see, you can see new hard disk default, it comes with a 90 GB. Let's say I given the size as 10 GB, and you can expand your new hard disk option. When you expand the new hard disk option, you can see some additional options. Within these additional options, we can see what is the maximum size, storage policy, location, disk provisioning. We already know disk provisioning, either thick or thin. Normally we recommend to go with a thin. When you choose the thin, and also the below option is sharing option. See, sharing option we have unspecified, or you can choose no sharing or multi-writer. So here you can see a multi-writer option. So that means when you select a multi-writer option, this disk will be can able to share it to the another virtual machine also. But you may ask the question, how this disk is assigned to the another virtual machine? How we can assign is, if you see the previous option in the add new device, see existing hard disk. You can log into the second app virtual machine 02, and then you can add a existing hard disk. You can map to the app one VMDK multi-writer disk. Okay, that is the purpose of this feature. Okay, so even if you have a multi-writer disk on your virtual machine level, this disk must should be accessible by your destination host. When you meet all these requirement conditions, then only we can able to perform our virtual machine migration successfully. And the same conditions applicable for all type of migrations also. But only thing is, when you are doing a hot migration only, all these conditions applicable. If you are doing a cold migration means VM is in a power off state. All this condition, even if it doesn't meet this condition also, you can migrate the VMs. Okay. And finally, I put one note here. So vMotion may fail if doesn't meet any of the host and VM level requirement. So whatever the points I explained here, if you doesn't meet any one point, if you're having some issue with one at one point level, vMotion may fail. Okay, and this is also an important point. Some of the interviews you may expect the question, what is a minimum requirement or what is the ESXi host level requirement to perform a vMotion? That time you can explain all these points. Okay, so hope you understand the vMotion requirement. Now we'll talk about the advanced concept, enhanced vMotion compatibility. So enhanced vMotion compatibility means EVC, in short form, we call it as a EVC, enhanced vMotion compatibility. If you try to understand this point, EVC is a cluster feature that prevents vMotion migrations from failing because of incompatible CPU. Earlier, we talked about one point is, if you want to migrate a virtual machine, CPU family should be same family, Intel or AMD. Within the Intel family, generation should be same generation. But there are some scenarios, our office environment, let's say you buy a new server in 2022. This year you brought a new server. Let's say the processor model is Intel Sandy Bridge generation or AMD generation 1 or AMD generation 3 server you bought in the 2022. But in the next year, 2023, our servers, our vCenter requires some additional host. When you buying a new server, by that time, our AMD generation 3 is old. We need to buy a latest generation, AMC generation 4. I'm just giving example, but sometimes generation will be generation 5, 6, 7, and so on, any generation. But try to understand the differences. Let's say my vCenter is running with the generation 3, but in future, I am planning to add a AMD generation 4. That means our generation is mismatched. If in during this scenario, what VMware recommend is you can enable a EVC mode option. When you enable EVC mode, even though your CPU family is same, if your generation is different, still we can migrate the virtual machine from one host to another host. That same point highlighted here. The importance of EVC is because of incompatible CVs, vMotion will fail. To address this scenario, VMware given one feature called EVC, and EVC is a cluster feature. See, this feature works at the cluster level using a CPU baseline to configure all processors in cluster that are enabled for EVC. Let's try to understand this diagram. Let's say within our cluster, we have three ESXi hosts, all the three ESXi hosts running with a same CPU family. Let's say I given CPU families some X. X means either a Haswell processor or AMD generation 3 or generation 4. All are in a same processor. So clustered enabled for EVC. We already enabled the EVC option also. When you enable the EVC, the benefit is if your host is not part of this EVC cluster, if the host is by outside the cluster, that means here the processor families, I'm given some K. If you want to migrate VM from EVC to another host, definitely your migration will be failed. What the VMware recommend is, if you have a different CPU family within the Intel generation different, during that scenario, to address this failure scenario, VMware recommend to enable a cluster level EVC feature. So EVC means the baseline is set of CPU features is supported by every host in the cluster. So let's quickly observe how we can enable the EVC in our cluster level. Let's log into vCenter. Let's say I have a cluster one. If you want to enable EVC on a cluster, right click the cluster, go to the edit settings. This is one method. And another method is select the cluster, right side, go to the configuration tab. Under configuration tab, you can just configuration section, you can look for a EVC option. See, under configuration, we have a VMware EVC. When you see the EVC, by default, VMware EVC is disabled state. Okay. When the EVC is disabled, we cannot able to migrate the VM from one ESXi host to another host in case of CPU technology is different. Let's say when I select the ESXi host 4, ESXi host 4, what is my processor here? In our lab, all are in a same CPU family. But let's try to migrate the virtual machine. ESX1 and any virtual machines here, or no virtual machines here. Let's say app VM1. Currently app VM1, it is running on a ESX2. Now I'm trying to migrate from ESX2 to 74 ESX. So this ESX is a ESX4 actually. I added with a IP address, but ESX2 to I'm trying to add to the migrate to the ESX4. So right click the ESX host, go to the migrate and select the compute source, click on next. And now I'm selecting a ESX4. When you select ESX4, it is showing us there are compatibility issues that need your attention. So we need to fix this compatibility issue. There is information button, or you can just click on a show details. When you click on show details, see, just try to understand what is error messages. This error messages says that vMotion interface is not configured. So vMotion interface means our VM kernel port group is not configured and we need to configure. And also too large clock skew was detected. That means the time synchronization also not configured. So that is a warnings and all we can ignore, but errors we need to address. So no VM kernel port group, that is the issue. Suppose in our lab, all the systems are in a same CPU family, no issues on the CPU technology. But if you want to enable a CPU with the same technology, Haswell technology, how we can enable is log into the vCenter, select the cluster configuration tab, EVC, right side. It is in the disabled state. If you want to enable EVC, click on edit. See here, currently EVC in a disabled state. Enable EVC for AMD host. If you want to enable EVC within a CPU family, within a AMD, we can enable, select the AMD. You can see the AMD CPU mode, either mode or generation, any name we can use. So under the CPU mode, just select the drop down menu. You can see AMD have a multiple generations. Okay, based on the RV tool report, whatever the generation you are using, you can choose your relevant generation. But currently our lab ESXi hosts all are a Intel processor, so we can skip this option. But just try to understand, if you have AMD host, you can use this method. Okay, suppose if you have Intel method, just select this option, enable EVC for Intel host. Under CPU mode, you can just click on the processor generations. See, normally Intel CPU models are, it's started generation from Merom. Merom is the first version of generation, and later they keep on changing the generation's name. I give an example as Sandy Bridge, Ivy Bridge, Haswell. If you see, our lab ESXi host is running with Haswell generation. So if you want to enable on our ESXi host level, the recommended generation is Intel Haswell generation, and this Haswell generation features. Like if you buy a iPhone 12 or iPhone 10, iPhone 10 and iPhone 12, there will be some feature difference. Same way, this processor also, if I select a Ivy Bridge, there is a some processor difference. Okay, so even the compatible, this host cannot be admitted to cluster enhanced most compatibility, because there is a some power on virtual machine. If you want to enable the EVC mode, all virtual machines should be powered off, or migrate all your virtual machines to another running host. So that is the reason there is a compatibility warning. So let me cancel this, quickly power off our virtual machines. So right click the VM, power, shut down guest OS, and same way power off the new virtual machine also. Power, There is no VMware tools. That's why these options are not highlighted. So let's quickly power off. So when the virtual machine is power off, but in our lab environment, I just powered off. But in the production environment, remember that migrate your running virtual machine to another cluster or another ESXi host. Okay, once you migrate only, when your cluster and ESX host are free, then only you can enable the EVC mode. So select cluster, go to the configure VMware EVC, select enable Intel host and choose your relevant generation. Our lab host relevant generation is Haswell. So select Intel Haswell generation, click on OK. Even if I want to try to another one also, it is showing as succeeded, but later while migrating, you may face some issues. So better to go with the compatible version. So now click on OK. When you click on OK, the EVC state is showing as enabled state. And what is the mode? It is on a Intel Haswell generation. This is a description for the compatible. Even the Intel Haswell is supported for some additional models also. Okay. It mentioned host with the following processor types will be permitted to enter the cluster. Okay. These all models are combinedly work as a same model. Okay. And also there is a features information and also CPU features set. What is the features available in the CPU? Okay, and also graphics mode also available. Okay, so this option only I'm trying to explain in our slide. If you want to enable EVC, even your other ESXi host must join to the EVC mode, or else when you're trying to migrate a VM, migration will be failed. Now, let's talk about the EVC cluster requirement. If I want to create a EVC cluster, what is my requirements? All the hosts in the cluster must meet the following requirements. So use the CPUs from single vendor. Single vendor means either Intel or AMD, and use the Intel CPUs with Merom. Merom is the main first generation of processor. Merom micro architecture and later any versions you can use, and even use AMD also. First generation is the first model, and then you can start use the latest version. Any model you can use, and be enabled your hardware virtualization. If you remember in our ESX host installation class, we discussed before install ESX server in our BIOS level. If it is an Intel motherboard, we need to enable VT option, and the AMD motherboard enable V option. So we must be enable hardware virtualization option if you want to enable a EVC mode, and be enabled execution disable technology. So these technologies will come automatically with your processor family. Okay, NX means no execute technology, Intel means execute disable technology. So this option main purpose is, let's say, let me explain this point. uh, how I'm trying to explain is, let's say we have a Intel Haswell processor. This processor have a 10 features. Let's say I have the features 1 to 2. I have a features until the 10 features. Okay, and I have another Intel processor. Let's say Intel Sandy Bridge. This Sandy Bridge, when we have a Sandy Bridge processor, this Sandy Bridge processor have a multiple features. Let's say it have a features of 10 features or 11 features. When we enable the EVC mode, what it will do is it will disable these additional features. Okay, I'm not going in deep of features information. Just try to understand the basic funda. Let's say my Haswell processor have 8 features. Let me highlight the color with any one color. Let's say blue. And my Intel Sandy Bridge have a additional 3 features. But when we enable the EVC mode, it will match your processor features with your new version of feature. The same features you can enable on a Sandy Bridge, and it will make it disable the advanced features. When it is disable the advanced features, this Sandy Bridge processor also works the same like a Haswell. That is the importance of how the enhanced vMotion compatibility works. So that is only they're highlighting here. Be enabled for execution disabled technology. So that means whatever the additional features and all, it will disable. It will enable only the equivalent matching features. Okay, and be configured for vSphere vMotion migration. So obviously when we enable EVC, we should also choose the requirements of all the vSphere vMotion requirements, and applications in virtual machine must be CPU ID compatible. CPU ID means every CPU have a unique ID. That unique ID should be compatible. Okay, this is about the vMotion, how the vMotion works, and the vMotion advanced feature, which is enhanced vMotion compatibility. Now we are going to talk about the storage vMotion. So within the storage vMotion, it's a simple storage vMotion can be migrate power on virtual machine from one data store to another data store. If you see in this diagram, vMotion means moving from one host to another host, and storage vMotion means only the storage level vMotion. It's not changing the host. Moving virtual machine disk from one data store to another data store. And when you migrate, when the VM is power on, we call it as live migration, or we call it as hot SvMotion. When the VM is in power off state, we consider as a cold SvMotion. Okay, and now as similar as vMotion, we'll also talk about the SvMotion use cases. So here are the SvMotion key use cases, storage vMotion key capabilities and use cases. In which scenario we'll go for a storage vMotion? Normally there are four scenarios. Scenario one, data store maintenance schedule. Earlier in our vMotion scenario, we discussed about host maintenance schedule, but here is a data store maintenance schedule. So during that scenario, move virtual machines from one host, one data store to another data store. And insufficient data store space. Suppose your data store space is full. During that scenario also, you can go for a SvMotion. And also disk provisioning types. Even if you want to change your virtual machine disk provision from thick to thin or thin to thick, vice versa, any scenario, you can also use the option for SvMotion. And also, if you want to change your virtual machine files from data store level, during that scenario also, you can recommend to do the SvMotion. Okay, this is the four SvMotion use cases, and we can quickly observe how the SvMotion architecture and SvMotion workflow. So same like our previous scenario, how the virtual machine migration from source to destination, same way, try to understand the SvMotion architecture workflow. Let's say how it will work is SvMotion works in a very much the same as vMotion, but only difference is only the disks are migrated instead. Instead of host migration, only host is still the same, only one host, but the disks are moved from one data store to another data store. But during the migration, it uses a IO mirroring architecture. IO mirroring means input output architecture to copy disk blocks between the source data store and destination data store. And normally the work how it will initiate is when you initiate a storage migration, uses VM kernel data mover. So data mover is one of the feature. It will use a data mover, or VMware storage vendors also provide a WAMI or WVAAI. VAA means vSphere storage address protocol interface array integration. This WAMI also will help you to copy the data from source data store to destination data store, and how it will use a mirror driver to move all the data. And once it's moved, it will cut from the source, it will activate from a destination. Now try to understand the description from the diagram. Let's say we have one virtual machine. It is running on ESXi host and the data store is source data store. When you try to migrate, what it will do is it will use a data mover technique, and using mirror technology, it will start move from source to destination. Okay, so that's how it will migrate from source to destination. Once it's completely using data mover, data is moved here, the VM will be completely disappear from source. It will activate from a destination. Previously, VM is working on source. Now it is working on destination data store. Okay, this is how SvMotion works. Now, SvMotion guidelines and limitations. So SvMotion guidelines, same like vMotion, even SvMotion also have some guidelines and limitations. Plan the migration and coordinate with administrators. Normal SvMotion we can perform along with your storage administrators, and perform migration during off peak hours. Half peak hours means non-business hours only, because if you're trying to do SvMotion during office hours, there will be a network performance or storage level latency issues. So VMware recommend to do only in the non-business hours, and ensure that host has access to source data store and destination data store. Even if you see our previous diagram, our ESXi host must have access to source data store and also the destination data store. If you do not have destination data store access, obviously our storage vMotion may fail. And the limitation, Independent virtual disk must be in a persistent mode. Persistent mode means permanent storage. Always our disks are stored in a permanent mode only. But if you are storing the disk is in a non-persistent mode, during that scenario, SvMotion may fail. So now, until now, we talk about vMotion, SvMotion, and cold migration. Now we'll talk about the cross-host or non-shared vMotion feature. See, non-shared vMotion means if you see the diagram first, we have two ESXi hosts and two ESXi hosts running in a same vCenter server, and it has a normal network. It is called as layer 2 network. But data store for ESX1 is different and ESX2 data store is different. Even though if you do not have a shared storage also, we can able to perform the migration. That migration call it as non-shared vMotion or cross-host vMotion. So cross-host vMotion migration enables a virtual machine to change its data store and host simultaneously. Even two hosts do not have a shared storage. Okay, so this technique combines the vSphere vMotion and storage vMotion into a single operation. So you can migrate between host and clusters without shared storage. Okay, this is the cross host vMotion. Suppose my company, as I said earlier, we have different data centers. One data center Hyderabad, another data center is in Pune or Delhi. During that scenario also, we can migrate the virtual machine from one vCenter to another vCenter. We can discuss in the next slide. So this is the migration between vCenter server instances. Let's say our vCenter here, it's migrating VM from source to destination, source vCenter to destination vCenter. But here only the difference is entire concept is same, but only new feature is required is enhanced linked mode. If you configure enhanced linked mode, the same vMotion can perform from one vCenter to another vCenter. Okay, our vCenter is in a source vCenter here. When you enable enhanced linked mode, our VM will start migrating to the destination host. Okay, so this is about the migration concepts. We'll quickly observe the lab first, and then that's it for today. We'll quickly do the lab first. So now, earlier when we are trying to migrate the VM, there is a VM kernel port group error. We'll fix that error now. I'm trying to power on the virtual machine. Both virtual machines are powering on. So when the virtual machine is in power on state, we'll try to observe what is the error we are getting while migrating. Currently, this VM is running on ESX2. I'm trying to migrate to ESX3. Right click, migrate. When you click on next, when you select the ESX3, it is saying that there are compatibility issues. What is that compatibility issue? Just click on show detail. It says that vMotion interface. So there is no vMotion interface. So we can configure the vMotion interface now. So to configure vMotion interface, as we know, we can configure on a ESXi host level, go to the configure and vSwitches. You can create a VM kernel port group here, or you can go to the distributed switch, select the port group, go to the actions, and you can choose a add VM kernel adapters. So we can add VM kernel adapters all at one shot. Okay, so add host. You can add the ESXi host, click on next. It is not showing ESX4. Maybe I haven't added the physical next to DV switch. Okay, so for the time being, we'll do these three hosts. Click on next. Now, what is the recommendation? We can choose the IP address 4 and you can choose the available services vMotion. When you select the vMotion for 3 ESXi hosts, we have to enter the IP address. Let's say IP address, we can use static IP address 192.168.10. Let's say we already used until 71.234. Let's give the IP as a 75 and another IP is 76 and 77. So three IPs are given and we have to give the subnet mask. When you enter one time, it will automatically fill on for a second one. Autofill option is available. So three host, our VM kernel details are given, and the gateway also. If you have gateway, you can use from the TCP/IP stack gateway. So view the gateways. Already we configured the gateways as a same gateway. So use the same like a TCP/IP stack gateway. If you have any different gateway, you can enter those details here. Okay. So we're going to use a same gateway 192.168.10.1. Okay, now click on next. So gateway configured, IP and subnet mask was given. Now click on finish. So when you click on finish, you can see our VM kernel port groups are configured. This information again go to the host, individual host. You can see here. See VM kernel 1 vMotion port group created, but the switch level, if you see the switch, it's not a vSwitch. Our DV port group VM kernel vMotion is configured on a DV switch level. Okay, and even enabled service is vMotion service. So once this vMotion is configured, now you can try to migrate the vMotion. Right click the virtual machine, go to the migrate and click on next. When you're trying to migrate the virtual machine, you can try to choose ESX2. See, compatibility is succeeded. Even if you choose ESX3, compatibility succeeded. ESX1, compatibility succeeded. If I select the ESX4, see again there is a compatibility error. So we'll talk about the error. What is error? See, it says vMotion interface. So there is no vMotion interface because this host not yet added to DV switch. That's why we haven't created the VM kernel port group here. But this VM we can able to migrate to ESX1 or we can migrate to ESX3. Let's select as ESX3. Click on next. Now click on next, next and finish. See, if you go to the monitor tab task, you can see migration will be in progress. And if you see the status also, when it was initiated, it's initiated on 1:53 p.m. But it is completed within how many seconds? Within 10:11. Within the 2 seconds, the migration is completed. Okay, that is the importance of vMotion. Suppose if you want to observe the other vMotion feature, other migration feature is SvMotion. We already did the SvMotion, moving from one data store to another data store. If you want to migrate the both host and storage, these two options, if you want to move this scenario, if I trying to migrate to another host, we'll see the testing. Compatibility succeeded because all the data store everything is possible, so we are able to migrate with power on state. But some scenarios, if you want to migrate to a different cluster or different model of processor, during that time if you want to change these two settings, virtual machine may require a power of state. And cross vCenter is nothing but a moving from one data center to another data center, like Hyderabad location to any of the remote location. Okay, so this is the options about the migration options. And enhanced vMotion also we observed when you select the cluster EVC mode. So EVC enabling is depends on your hardware models and processor. If your processor is AMD, you can choose this option. If your processor is Intel, choose Intel. And the processor generations you can find from the RV tool report. So accordingly, you can choose your relevant processor generation and click on OK. So that's it for today. If you have any questions, let me know. Today, we covered the migration features. See, cold migration we discussed, vMotion we discussed, storage vMotion, cross-host vMotion. Okay, and we also observe the lab and cross vCenter and all. If you want to test in your home lab, you can try. You can try to configure two vCenters and configure a vCenter linked mode and try to do the vMotion. Okay, but the concept wise same concept. That's it for today. If you have any questions, let me know.
Yeah. Is it possible to move VM from ESXi host of 6.7 to 6.5 or vice versa?
Yeah,
Do
if you
we
want,
concentrate on versions of ESXi host while moving?
yeah, correct. If you want to move from highest version of highest version of ESX to lower version, still it's possible, but there is some condition supply. The condition is our hardware version, virtual machine hardware version should be compatible, and the destination ESXi host CPU family and all the requirements should meet. When we meet the requirement, we can able to migrate. Even if you see in our lab, when we are migrating from ESX2 to ESX3, initially it says compatibility error. When we read the compatibility error, it says that there is a no VM kernel port group. Similarly, if you are using from lower version to higher version also, it will show some compatibility settings and error messages. Once we address those error, it will migrate.
Okay.
Okay. Any other questions?
And one more, that hot add feature is, applicable to versions like ESXi versions or OS.
Hot add is only on the VM level feature only. But only the limitations in the hotend is if you are using a Linux and Solaris, some of the operating systems default the specific operation vendor OS vendor says that that vendor by default they won't support. Like Solaris, if you want to increase the CPU or memory, the recommendation from the Solaris vendor is we need to power off and increase the CPU memory. And Red Hat Linux, SUSE Linux also, some flavors is supported, some flavors are not supported.
For example, in VM we are running 2003 OS. It is
Okay.
not. Yeah, is it possible to upgrade VM? I mean memory through hotend if we
Uh,
enable hotend feature.
yeah, if the OS is old version, definitely there will be a compatibility issues.
Okay.
So
The
it
best
should be the
way is
latest version. Yeah, best thing is latest operating system.
shut down the VM and then we will increase.
Yeah, correct.
Okay.
Any other questions? Okay, if no questions, we can end the session here and you can practice all the migration options at your home lab. Okay, thank you. Thanks for your time.
Thank you.
Thank you, sir.